From the moment our Earth was formed until today, every living organism has faced a common enemy: temperature. This is because every living being on this planet must survive through extreme heat and extreme cold. Our planet has freezing regions that can turn you to ice, scorching deserts with intense heat, and a few places that are perfectly balanced. However, temperature is never constant anywhere. It fluctuates between day and night, it changes with the seasons, freezing in winter and burning in summer. Nature has never changed. Instead, we who live within it have evolved to adapt to it. But humans didn't just evolve to suit nature, at some point we learned to control it. When humans discovered fire, civilization began to rise. As we developed, we started seeing temperature not just as a survival problem, but as science. Just think about it. We often understand heat and cold merely as a physical sensation, but their true meaning is far deeper. That is why in this video, we are going to explore these two extremes, heat and cold, in just 10 minutes. By the end of this video, you will definitely walk away with the satisfaction of learning something new. So let's dive in. For thousands of years, humans perceived temperature only as a feeling. They didn't measure it with numbers like we do today. They decided temperature based on the hotness or coldness they felt when touching an object with their hands. Later, through the development of science, we understood the true definition of temperature and discovered what actually makes an object hot or cold. Everything in this universe is made of particles. These particles create atoms. Atoms create elements, and these elements create different materials. So, atoms are common everywhere. Take any object and it contains billions and trillions of atoms. Inside these atoms, a type of vibration is constantly happening. In places with high temperature, these atoms vibrate very fast. In cold places, they vibrate very slowly. Let's look at this in detail with a practical example. What do we do to heat drinking water? We use either a gas stove or an induction cooktop. Here, the gas powering the stove and the electricity powering the induction plate are forms of energy. We use this energy to heat the water. The gas burning in the stove converts into kinetic energy, causing the atoms in the water to move. Essentially, the energy from the element, gas, transforms into a different energy within the water, forcing the atoms to move. Later, the energy stored in these atoms is released as heat. We determine the water's temperature by measuring this released energy. If a place has a high temperature, it means there is a high amount of energy there. So we perceive places with high energy as hot, and places with low energy as cold. But there are some general laws governing temperature, and nature is built upon them. No matter how much we control certain natural phenomena, we cannot change these laws. Let's look at them now. First, temperature always travels in one direction. That is, a cold object will not heat up without external energy. However, a hot object will eventually turn cold without any external influence. Heat always travels from a hot place toward a cold direction. This process continues until it balances with the environmental temperature. To put it simply, imagine we are drinking coffee. Over time, that coffee gets cold. Now, if we take that coffee into an air-conditioned room, the already cooling coffee will become even colder to match the room's temperature. From our perspective, the coffee might feel cold, but to the AC room, that coffee is still a hot object. Since heat travels toward the cold, the coffee loses more heat and becomes colder. This is the first understanding of temperature. Second, if you want to heat that cold coffee, you must provide external energy, and we take that energy from another object. Energy is never free anywhere, and we cannot create it. Energy only changes from one form to another. Third, temperature cannot achieve a pure maximum or minimum. Just as we measure temperature in Celsius, in international standards, it is measured using the Kelvin scale. Here, 0 Kelvin is the minimum temperature. 0 Kelvin equals negative 273 degrees Celsius. A place this cold has very little energy, but it never actually reaches the state of absolute zero. Temperatures can get infinitely close to zero, but never touch it. These three concepts are the natural understanding of temperature. Even nature cannot break these laws. At the same time, let's see how temperature bound by these laws works in the universe. Most of the universe is actually cold. The reason lies at the edge of the universe. For nearly 13.8 billion years, the universe has been cooling down. The universe itself acts to support this process. Whenever an object expands, the temperature in that area drops, it cools down. We see this phenomenon in everyday life. If you spray a perfume bottle for a long time, the bottle feels cold. This is because high-pressure gas is stored inside. When the gas is released, it expands, causing a cooling process known as adiabatic cooling. This process is what helps keep our universe cool. Since the Big Bang, our universe has been expanding, and this expansion is cooling it. Just as the universe cools through expansion, heat is created by stars. Life emerges only in the places where these two temperatures, heat and cold, are balanced. A balanced temperature creates the environment necessary for life to exist. This is the beautiful side of nature. But the universe has another side. I mentioned earlier that temperature cannot achieve absolute minimums and maximums. But hypothetically, what if it did? And did you know the universe might have reached the maximum temperature once? Yes, I said nature cannot break certain laws, but at the moment of the universe's creation, these laws had no meaning. That is why when the universe was created during the Big Bang, it likely reached its maximum temperature, known as Planck temperature. At this temperature, none of the elements, atoms, or particles we know today would exist. The very meaning of physics breaks down. There would only be energy, an amount we cannot even calculate. We wouldn't even know what type of energy it was. This was the starting point of our universe. On the other hand, we cannot reach the minimum temperature, absolute zero. The universe has never seen absolute zero Kelvin, but scientists have some hypothetical stories about what would happen if it did. If the universe reached absolute zero, it would be in a dead stage with absolutely no energy. It would be dark, with no light sources. A universe in this stage would be viewed as a useless garbage. That is why beautiful nature thrives only where temperatures are balanced. If you've watched the video up to this point, you've gained a new understanding of heat and cold. If you like this video, please like and subscribe. I will see you in the next video with more interesting content. Thank you.